Hi math lovers, welcome to Notes number 66. We're going to talk today about mathematical modeling, and I have to warn you, as your future statistics teacher, I'm going to teach you this a little bit differently than Ron does. I want you to get ready for your AP statistics class when you join me your senior year, okay? I have two problems picked out for us today, number 16 and number 20. So they're both in your book. I'm not even going to try to draw them. So if we could take a look at your textbook, roll all the way down here to number 16. If you take a look at this problem, well, Ron wants you to sketch the line that you think is the best approximating the data in the scatter plot. Then find an equation of the line. All right, so we're looking at this line here. I'm trying to think the best approximation. I went to this website that they had and I took a look at it, and I found that the coordinates that it goes through are 0, 2, and oops, I'm a little zoomed out here. The coordinates that it goes through, sorry kids, let me fix it. There you go, look, you can look back now. All right, the coordinates that it goes through are 0, 2, and 3, 3. And so you're creating a line of best fit. So you've done this for years. Old school, you'd find the slope. You find the slope is equal to, let's see, 3 minus 2 over 3 minus 0. So your slope here is 1/3. Really nice that the y-intercept here is 2. So straight up, I can say the equation of the line is 1/3. Y equals 1/3 x plus 2. Okay, so there's the equation of the line that they were looking for. Now, you're probably thinking to yourself, okay, that was really nice. We looked at the graph. We know how to do that. We don't need to do anything else. But what we're going to do is we're going to go to much harder problems where we're taking data from the real world and we are trying to fit a mathematical model to it. I don't need to tell you here this year how important modeling has become for all of our scientists and mathematicians. I'm down here at number 20, which says the table below shows the number of televisions in millions, excuse me, from 2000 through 2006. So we have the set of data here. I went ahead and I rewrote that data on the table for us so we could use it. Now stare at the data. Now, how in the world are you going to have a line of best fit through that data? The method that we used for the first problem is not going to work here for our second problem. Any ideas? All right, so what I want you to do is to go down, grab your handy dandy TI-84 calculator. And we're going to go ahead and we're going to put this data into our calculators. But friends, before we get started, let's make it easier on ourselves. Instead of using the actual year, let's go ahead and let's use 0 and for 2000, and 1 for 2001, 2 for 2003, 3 for 2003, 4 for 2004, 5 for 2005, and 6 for 2006. That will make it much easier on me. All right, our X value will be the year, okay, the year since 2000. All right, so go to your calculators. Go to your calculators. You're going to turn it on and go to your stat menu, your button right here that says stat. Now, that button at the top, it says edit, calculate, tests. We're going to put data in, so we're going to use edit, so hit enter. I've already put my data in for those 2000. Oh, that's much better. I need a better tilt. What I'm going to do is I'm going to go over and I'm going to clear this first list. So I highlight L1 and then I hit clear. Do not hit delete, hit clear. You know what delete will do? Yes, it will delete your list. 4, 5, and 6. Okay, so now our numbers are a little bit easier for us to work with. Now we want to do some calculations, right, with that data. Maybe the first thing I want to do is look at the scatter plot of it. So right up top here where it says stat plot, I'm going to hit second to use stat plot. I want to tell my calculator, hey, I'm going to use this first one. I'm going to turn it on. And I want to make a scatter plot, which is the first one that's highlighted. My X is list 1, my Y is list 2. Oh, that's awesome. Okay, so I quit this mode and I want to graph it. Now, fight the urge. Instead of using graph, you're going to go to zoom and go all the way down to number 9, zoom stat. Hopefully you're trying this along with me on your calculators. And there is the scatter plot. Now, so the first thing you're going to do is take a look at that. How does that look? Do I have a graph on here? Oh gosh, I got to clear that. That was terrible. It's amateur hour here, Glennon. All right, there it is. Does this look straight enough? Does it look like a graph? Well, it looks like it has a slight curve to me, but we're going to proceed. Ron says to find a linear model. So I'm going to go ahead and find a linear model, all right, just like he said. So I'm going to go to Stat, and now I want to calculate, okay? I want to go to, I'm going to hit Enter because I want to calculate. And notice that oops, I'm at the wrong menu. Stat, calculate, and I want to go down here to number 4. Number 4 says LinReg. So hit Enter. List 1, list 2. Frequency list, I want you to clear that, so there's nothing in there, and you're going to hit Calculate. And there is my linear model. It's telling me the model is y equals 9.28x plus 238. All right. Now, you might have an R down here, an R value. All right. I don't have my diagnostics on. So what I'm going to do, and this is where my stat class is going to come into, this is what you're going to do in my stat class. You're going to go to second, and then all the way down here to answer is blue, and it says catalogs. Oops, sorry. Second, and then catalog. Oh, not the answer. Down here is 0. And hit catalog. All right. So all the way down, what you're going to do is go all the way down to diagnostics. All the way down to letter D, diagnostics. And that's going to give me our correlation coefficient. I'm going to turn my diagnostics on. I actually have to hit Enter, and you'll see diagnostics are on. Now go back to your stat menu, go over to calculate, and back to LinReg. And I want to calculate one more time. Now notice that my R values have come up. Now, my friends, the R value is always going to be between -1 and 1. The closer it is to -1 or the closer it is to 1, the better the straight line it's going to be. How scattered the points are. This 0.9 is very high. This is a very strong correlation coefficient. All right, so it is a good line. It is good. I'm going to use R squared. When you get to stat class, we'll use that R squared, and we will say that 92% of the variability in the number of televisions can be accounted for by the variability in the years. All right, so you will use that, and A and B are obviously your slope and your y-intercept. I want to just point out one more thing, that if you go to your stat menu, over to calculate, and you scroll down, you have a second LinReg at number 8. It doesn't matter which one you use. Notice if I go ahead and I calculate it again, I'm going to get the exact same format, but notice that my y-intercept comes first and then my slope. Okay, so 2 different ways to do that. I'm gonna real quick, if you're done and you get that, you can stop the video here, but I'm gonna keep going, and I'm gonna write down those values, those directions for you, so as how to do this on your TI-84. All right, so what you want to do first is you want to go to, obviously put your data in. You're going to turn on your calculator. Turn on TI-84. Okay, and you're going to use the stat menu, and you're going to go over to calculate, and of course enter. List 1, we put in the year, which would be our T. Again, we modified it. List 2 are the TVs, okay, the number of TVs. And then we went back to the stat menu. We hit calculate again, and we went to number 4, LinReg. Okay, LinReg. And that came up as LinReg AX plus B. I'm writing these notes out so you can be writing them too, so you have them. So when you were looking back and saying, how did we do that? You have that, all right? And that gave me A is equal to 9.28. We'll just truncate that variable at 2 decimal spots, and 238.28. I'm not going to talk about correlation coefficient here because, you know, that's your stat class. So your equation would be, so from this, you would say your equation is y equals, or we should really give our context, shouldn't we? You should say the number of TVs. That's the way I'll make you do it in stat class. I'll even make you put a hat on it when stat class. Is, let's see, 9.28 times the year. obviously the year since 2000, plus 238.28. All right, so when you get to AP Stat, that's the way you're going to write it, definitely in context. Ron, he just has your 9.28, X plus 232.28. All right. The other thing I showed you is your stat, how to make a stat plot. If we were in the classroom and we had a quiz, the first thing I would do on the quiz is I would make you all make a stat plot on your calculators, and I would walk around the room and make sure you could do it. Maybe on your quiz this time, I'll have you do a stat plot and do like a selfie with that. Oh, that would be fun, wouldn't it? Put that one in my back pocket. That's a nice little Easter egg for you guys that stuck around for this part of the video. All right, so you want to go to second, hit the second menu, and you're going to select stat plot. You're going to go to number 1. You're going to turn it on. You're going to pick your type, which we picked the scatter plot, this one. And we had, let's see, L1, L2. So we put in our X was L1, our Y was L2, and then we went to graph it. So we went to zoom, and then we selected number 9, zoom stat. Okay, zoom stat. All right, very nice. That was good. Okay, so again, two fun problems. This is basically just how to use your graphing calculator. And this one at the top, this is a total review from your Algebra 1 class where you had the rulers and you'd get the line out. You'd see which was the line of best fit. You'd pick 2 points. Instead, we're all grown up now, and we're going to use mathematical modeling, and we're going to use the line of regression feature on our calculators. Have fun with your stat class. Have fun with your problem set, kids.